get to the video yet. Alright, now, are we ready? We're going to go through indirect titration. So this is the second video of that series. Does everyone like that? Okay, now, let's get into it. So, quick revision. Quick revision is, we just did back titrations. And if you remember, the key to back titration was one of the reagents is in excess. One of the reagents was in excess. The titration happened in the second step. Okay? Got that? Yes. Now we're going to look at indirect titrations, because indirect titrations are indirect. Okay? Now, so an indirect titration works like this. We've got two chemicals that are reacting together. They are my reagents. And the two chemicals produce a product. The product I'll put a question mark under. The product is C. Put a nice little thing around C. Okay? Now, we might be trying to work out, let's assume we are trying to work out the concentration of A. If I gave you the first equation, and if I said, you know the number of moles of C, what could you tell me about A?
This is an equilibrium.
It's not an equilibrium question, no. If I just gave you equation number 1, and if I told you I know the number of moles of C, what can you tell me about A? What's the equation tell you? A to C is 1:1.
What?
It's not rocket science. Okay. 1:1. So if I tell you the number of moles of C, stoichiometry tells you straight away you know the moles of A. Wow. That's amazing, isn't it? Now, there could be over here, associated with moles of A, there might be a volume there. So then I could go further and say, well, what's the concentration of A then? Could ask you to do that as well. Okay? The difference with this indirect titration is, and again the titration happens in the second step, but we're not taking the reagents, we're not titrating any of the reagents, we're titrating the product. Not the actual reagent. So this is my product. Okay? And I'll titrate the product. This is my titration step. Here. This is my known. So E is a standard solution.
How would you separate the C from the D when you chuck it in the...
Oh, you'll see how we do that when we get to an example. You'll see how we get that. Okay? Alright. So C is a reactant. Sorry, it's not a reactant. It's a product. But indirect titrations. We take C, we titrate C with another known, and now we've got a titration again. So if we know the concentration of E and the volume of E, the titration, again it could be an acid-base titration, we work back, we know the moles of C. If we know the moles of C here, it's the same as the moles of C there. If I know the moles of C there, it's the same as the moles of A. So it's like a back titration. That's why I try not to distinguish between either of them, because they're still pretty much the same. One, you just take the reagent, and then this one you take the product.
So you don't have the moles of C. And you react it with E, which is known moles.
Yeah.
You know then you grab the ratio,
yeah.
Work out the moles of C down there, and then it's just that's it.
Sounds easy, doesn't it? Okay. The only thing I didn't mention, again, was that you have to have an excess of B. You've got to make sure that all of A reacts. They have to go all of it.
Otherwise,
but we don't do anything with the excess of the reagent in an indirect titration. We just actually take the product and we titrate the product and go from there. Okay, so this is an example here of bleach. Okay, you don't have to worry about that, but this is the thing I'm trying to work out the concentration of. Okay? It is reacted with an excess of ions, and it produces iodine. Here it is. Iodine is a product in reaction 1. Again, note it's 2 reactions. If it's 2 reactions, it's either an indirect or a back titration. But the process of calculating it is the same. Now, what I do is the iodine from the first reaction, all of it, we take, and there it is, we titrate the iodine with this one here called thiosulfate. That's the reaction for the titration. So just a straight titration. So I now know over here I'll work out the moles of thiosulfate from titration. I can work out the moles of iodine ratio, 2:1. Whatever the moles of iodine here was, it's the moles of iodine there. And from the moles of iodine there, I can work out the moles of hypochlorite in the bleached sample. So it does this, it's a bit like I always say it's back titration. So we start from here, we work out that, then we work our way over to the iodine, and then from equation number 1, back to the hypochlorite. Okay? Now, I never said it was simple, okay? Didn't say it was simple, but if you can watch the videos over again, I will put them up tonight.